Hello, I'm Neil, and in this video I'm going to talk about cloud disaster recovery. After all, disasters always happen, and whilst we can't avoid them, we can take actions to make sure the impact is minimal. Let's get into it. Unfortunately, stuff goes wrong. Failures happen. All we can do is be prepared for when that occurs. Having a good action plan of how to deal with the discovery of a disaster will enable you and your teams to recover from it very quickly. With a good enough plan, the end users won't even notice, and the system will just be a little bit impaired for a bit. This video playlist is based on my book, Who Moved My Servers, available on Amazon now. One of the easiest ways to combat server failure is to have more servers. Enterprise level servers are designed in such a way that you can run multiple servers serving the same content. This is called a cluster. Nearly all database servers are written to function this way, so that no data is lost. These cluster nodes can operate on their own, but work best in a cluster. After all, if one fails, then there's some friends for it to carry the load. One of the advantages of using infrastructure as code means that we can build a replacement server very quickly. Having a server in a cluster means that whilst the server fails, the service can still provide the services to the users. It's just in a slightly impaired state. It might not be able to serve as many requests as it can normally, but it will still work. SPOFs, or single points of failure. If your application is designed in such a way that it has a single point of failure, it's time to redesign that application. Closely related to clusters, single points of failure might occur where you've got a cluster with only one server in it. Part of the system often overlooked is load balancers. You might have designed your service to run on multiple web servers, but you only have one load balancer in front of it. This would create a SPOF. You want at least 2 load balancers in front of your web server cluster. If you're working in the cloud providers, then a lot of this is dealt for you already. If you're using their services, when you request a load balancer, for instance, you get 2 whether you like it or not. Amazon's S3 bucket service is designed for this level of resilience. Another common single point of failure is where you have an office connected to the internet. If you've only got one internet connection, then once you've migrated all of your servers to the cloud, you might find that your internet connection goes down and your office can no longer work. This is something to bear in mind before moving the servers, or something to bear in mind when setting up internet connections. When duplicating servers and nodes in a cluster, it's important that the configuration stays the same. This is so that no matter where the service goes through the path, the experience is the same. If you've got a component within the cluster that's configured slightly differently, it might still work, but this may also give you odd errors that are really difficult to track down. To this end, automation and infrastructure as code can help us here as well, and avoid configuration creep. Configuration creep occurs when a manual change happens on a server. The configuration is quite literally creeped away from what we've defined in our code. If you're running Puppet, then the agents by default run every 30 minutes to align the configuration in the code with the configuration on the server. This is to avoid configuration creep. As far as disasters go, the most vulnerable place, other than SPOFs, is Snowflakes. These are servers that have been set up long ago. They don't have configuration management looking after them. They don't have configuration code. They're a completely manually built server that everyone is usually scared to touch in case they break it. There's not a lot to be done for these Snowflake servers other than make sure you've got a good backup and have a project to replace it as soon as you can. And I've spoken a bit about configuration management here. And that means that we can build a server really quickly. We lose the server, we can build it again. However, the data, not quite so easy to recover. This is why the majority of databases work in a cluster, where they replicate the data amongst the nodes. This works in a very similar manner to RAID on hard disks. The data is striped, stored in multiple places on multiple servers. The simplest configuration for this is where each server has an exact duplicate of the code and the data. However, this can run into latency issues. Because we're synchronizing the data across multiple servers, the server that receives the data first has the latest, and the other servers in the cluster then have to catch up. This is what's referred to as eventual consistency. Essentially, it's a caching problem. Not all the data is the same in all the same place. One way to defeat this on a simple level is just to have 2 copies of the data. If you've got 3 servers in your cluster, then they don't all hold the same data. 2 of them will hold the same, and the third one will hold slightly different data. This is why the data is sharded. One data set will exist on 2 servers, but not all 3. With all the coming and going of these server nodes, we need some way of keeping track of where they are. Service discovery, often implemented through DNS, enables us to find any service and where it's running. The basic way this works is when the server is available and ready for work, it then registers itself with some sort of registry, be it DNS or a service discovery registry. Anything, one, person or service then wanting to access it can look it up and see exactly where it is. In the next video, I'll be discussing the software development lifecycle. Please subscribe to the channel and click the notify button if you want to get notified of when that video is available. If you like this video, I'd really appreciate a like. Till next time,